These are examples from section 12.3, Inscribed Angles of a Circle. Previously, we had talked about central angles of a circle. Central angles are angles whose vertex are at the center of the circle, as with circle P here. So circle MPN is a central angle, and we learned that whatever measure of this angle is the same measure of the intercepted arc. So in this case, for instance, if angle MPN were 85 degrees, the measure of angle MPN, the central angle, is the same as the measure of arc MN. So this would also be 85 degrees. In lesson 2.3, you learned that with inscribed angles, their vertices lie on the circle. For instance, this angle here is an inscribed angle because the vertex is on the circle. Suppose these points were A, B, and C. You learned by the Inscribed Angle Theorem that this angle here, this inscribed angle, is always exactly half the length or measure of the arc that it intercepts, right here. So the measure of inscribed angle BAC has to be half the measure of arc BC. Example 1. What are the values of A degrees and B degrees? Here we have a circle, and we've got several inscribed angles. Arc PT, the measure of it is named A degrees. So we're talking about the measures of these arcs. And then angle B, or B degrees, is coming from angle PRS, this one right here. So this is an actual inscribed angle. They're asking us for the values of those. So first of all, looking at A degrees, notice that A degrees, the arc for it starts at P and goes over to T. And if you'll follow those segments, those chords inside the circle, they both end up at point Q. And we have an angle or a measure for angle PQT, which is 60 degrees. So despite the fact that chord PR is kind of obstructing our view, hopefully you can see that angle PQT is the angle that's inscribed and gives us arc PT, and therefore the measure of arc PT will be A. So by the Inscribed Angle Theorem, we can now say that the measure of angle PQT is equal to 1/2 the measure of arc PT, the intercepted arc. Now it's just a question of substitution. The measure of angle PQT is 60 degrees equals 1/2 times the measure of arc PT, which is A degrees. Now we solve for A. Since A is being multiplied with 1/2, we divide by 1/2, or that's the same as multiplying them by the reciprocal of 1/2, which is 2. So we multiply both sides by 2. These two 2's divide out, and we're left with A degrees. On the left side of the equation, 2 times 60 degrees is 120 degrees. Therefore, A degrees is 120 degrees. Now, for B degrees, notice B degrees is angle PRS. And angle PRS intercepts two arcs. The arc we just found, PT, which is 120 degrees, plus the arc right here, TS, which is 30 degrees they give us. So we're going to be using arc addition. You can either add these first and then use the inscribed angle theorem, or you can put it all together like this. So by the inscribed angle theorem and arc addition postulate, we can say that the measure of angle PRS right here is equal to half times the sum of the measures of the two arcs. The measure of arc PT plus the measure of arc TS. Together, PS, that will give us the entire arc that's being intercepted by the angle. So this would be an equation you could use. Now we substitute in what we know. The measure of angle PRS is B degrees, equals 1/2 times the measure of arc PT, which was 120 degrees, plus the measure of arc TS, which they give us, is 30 degrees. B is already solved for, so it's just a question of doing the calculations. B degrees. Remember, we have to add before we can multiply here because of the parentheses. So we have 1/2 times 120 plus 30 is 150 degrees. 2 goes into 2 once. 2 goes into 150 75 times. So now we have 1 times 75 over 1, which is simply 75 degrees. So B degrees is 75 degrees, this angle right here. Example 2. Find the measure of angle 2 in the diagram. Here we have a circle, and angle 2 right here is angle ADB. Well, at first we take a look at the angle. We don't have that angle, and we also don't have the intercepted arc, AB. So we can't use the inscribed angle theorem as it is. However, notice the inscribed angle right here, AB, is not only an inscribed angle, or the arc, is not only an intercepted arc of this inscribed angle, but it's also an intercepted arc of this inscribed angle. And this inscribed angle, ACB, is 38 degrees. And you learned in the notes by the inscribed angle corollary number 1 that two inscribed angles that intercept the same arc happen to be congruent to each other. So since this arc is being intercepted by this angle and the angle we're looking for, that means angle 2 has to be the same as this angle. So we can write by the inscribed angle corollary number 1, the measure of angle ADB equals the measure of arc AB, which equals the measure of the other angle ACB. They both equal the measure of this arc. And so substituting on what we know, the measure of angle ADB is really the measure of angle 2. The measure of arc AB, we don't know what that is, but whatever it is, we know it's equal to the measure of the measure of angle ACB, which is 38 degrees. So by the transitive property, if the measure of angle 2 equals the measure of arc AB, and the measure of arc AB equals 38, then the measure of angle 2 has to equal 38. Example 3. Find the measure of angle 1 in the diagram. Here we have a circle. We have angle 1 right here, which is also angle MPN. Angle MPN intercepts arc MQN, which happens to be a semicircle. And we know that because this is a diameter, it goes through the center. So arc MQN is a semicircle. And you learned in the notes by the inscribed angle corollary number 2 that an angle inscribed in a semicircle has to be a right angle. So this angle right here, angle MPN, which is the same as the measure of angle 1, has to be 90 degrees by the inscribed angle corollary number 2. This is the semicircle that it intercepts, so this has to be 90 degrees. Example 4. Find the value of each variable in the diagram. Here we have a circle with several chords and inscribed angles. We have two variables, p degrees and q degrees, that we need to find. Notice that the inscribed figure inside the circle happens to be a quadrilateral with 4 sides. Since it's inscribed and it's a quadrilateral, by the inscribed angle corollary number 3, which says the opposite angles of a quadrilateral inscribed in a circle are supplementary, then we can state that opposite angles have to add up to 180 degrees since they're supplementary. So first of all, the measure of angle W plus the measure of angle Y, which is opposite, has to equal 180 degrees. And by the same corollary, the measure of angle Z plus the measure of angle X, its opposite angle, also has to equal 180 degrees. At this point we substitute in what we know. The measure of angle W is p degrees plus the measure of angle Y is 90 degrees equals 180 degrees. And the measure of angle Z is q degrees plus the measure of angle X was 58 degrees equals 180 degrees. Now solve both linear equations and you'll get both variables. So we subtract 90 from both sides here, and p degrees is 90. So we have a 90 degree angle for p right here. And when we subtract 58 from both sides of this equation, we get 122 degrees for angle Z, which is q degrees. So P is 90 degrees and Q is 122 degrees. Example 5. In the diagram, line SR is tangent to the circle at Q. Line SR is tangent to this circle at point Q. If the measure of angle PMQ is 212, if the measure of arc PMQ is 212 degrees, so from here over to here is 212 degrees, what is the measure of angle PQR? PQR, this one right here. Now remember, this angle doesn't stop where the circle is. It stops clear over to the line that's tangent. So taking a look at this problem, it's a classic tangent to a circle problem with a chord or another side of an angle going through it. This, of course, is a straight angle. And you learned by the Tangent and Chord Theorem that says or states that angle formed by a tangent and a chord, here's the chord, is half the measure of its intercepted arc. So if we're looking for this angle right here, this measure, then it would be half the length or the measure of this arc right here, arc PQ, because this is the arc that this angle intercepts, right here. And so there's a couple of ways you can do this. One way is you can just use this one and then use supplementary angles to find this one. Or you can go ahead and find this arc first, which is what I'm going to do. So before we use this, by arc addition postulate, we can say the measure of arc QMP plus the measure of arc PQ, the one we're looking for, or the one we need, equals 360 degrees, the degrees in an entire circle. Once we set that up, then we plug in what we know, or substitute in what we know. So the measure of arc QMP was 212 degrees, plus the measure of arc PQ, which we need right here, equals 360 degrees. When we subtract 212 from both sides, the measure of arc PQ, we end up with 148 degrees. So now we know this is 148 degrees, and we have enough to use the tangent and chord arc theorem now. So by that theorem, the measure of angle PQR, so right here, is equal to half the measure of arc, the one it intercepts, PQ. Substituting in what we know once again, the measure of angle PQR we're looking for equals 1/2 times the measure of arc PQ, which we found to be 148 degrees. 2 and 148 are divisible by 2. 2 goes into 2 once, and 2 goes into 148 74 times. So now we have 1 times 74 degrees over 1, or just 74 degrees. So the measure of angle PQR is equal to 74 degrees. Right here. Example 6. Find the value of each variable. Cite a definition, postulate, or theorem to justify each found variable. So we have this circle. We've got quite a few angles to find and arc measures to find. We also have a tangent ray. And so let's begin. Just because these are A, B, C, D, and E doesn't necessarily mean we have to find them in that order, alphabetical order. So as we look around, there's several ways we can start this, but I'm going to start focusing in on B, this one right here. Take a look at angle B here. UXV, this angle right here, is the measure, B's measure. Notice that it intercepts this arc right here, arc UV, and we have that measure. It's 110 degrees. So by the Inscribed Angle Theorem, just the regular old theorem, the measure of angle UXV is equal to 1/2 times the measure of arc UV, Substituting in what we know, this is B degrees for this angle, equals 1/2 times the measure of arc UV, which is 110 degrees. 1/2 of 110, or you can look at it as 2 goes into 2 once, and 2 goes into 110 55 times, and therefore we have B degrees is equal to 55 degrees. There's our first answer. I'm going to cross that out and write 55 degrees there. We may or may not end up using the 55 degrees, but it's there if we need it. Then I'm going to focus in over on, take a look at the semicircle UXW right here, and notice that angle UXW intercepts the semicircle over on the other side. So a semicircle WVU. And so, since that's a semicircle, by the inscribed angle corollary, it's number 2. Semicircle UXW, UXW, and it all gives us semicircle also UVW. And because this is a semicircle being intercepted by this angle, we can now say that the measure of angle UXW is equal to 90 degrees by that corollary. So now we know this is 90 degrees. Then you take a look at A degrees. Notice A degrees is an angle VXW, and it intercepts this right here, this D degrees. And so notice, before we can find one of those, because we don't have either one, notice that A is adjacent to B, which we found, 55 degrees. And these two together make a right angle. So, by the definition of complementary angles, the sum of the angles are 90 degrees. We have the measure of angle UXY plus the measure of angle YXW is equal to 90 degrees. Again, UXY, this one right here, and the measure of angle YXW, this A degrees, equals 90. Substituting in for the measure of angle UXV, which was B degrees, is 55 degrees. Let's see, that was, Y. Plus the measure of angle YXW, which is A degrees, equals 90 degrees. So this angle here plus A gives us the whole right angle. Definition of complementary angles. Subtract 55 from both sides, and A degrees is equal to 35 degrees. So we found A degrees. Cross that out, 35 degrees. Then, or now we can find arc D, the measure of arc VW, which is D degrees, now that we have A. So, again, by the inscribed angle theorem, we can state our equation as the measure of angle VXW is equal to half the measure of arc VW, its intercepted arc. Substituting in what we know, we now have 35 degrees here equals 1/2 times the measure of arc VW is D degrees. Solving for D in this equation, we multiply both sides by 2 to get rid of the 1/2. The 2's divide out, we're left with D degrees, and 35 times 2 is 70 degrees. So D degrees, by the inscribed angle theorem, is 70 degrees. Place that in. Now let's turn our attention to E degrees. This angle here, YUX or WUX, notice it intercepts arc WX, which is 76 degrees. So we have enough there to use the inscribed angle theorem. So by the inscribed angle theorem, once again, the measure of angle U is equal to 1/2 the measure of arc WX. U right here is equal to half the measure of this arc right here. And substituting in our values, we have E degrees is equal to 1/2 times the measure of arc WX, which is 76 degrees they gave us. E's already solved for, so just calculate this. 2 goes into 2 once, 2 goes into 76, let's see, 38 times. So 1 times 38 degrees over 1 is 38 degrees. And so we come over here, cross out E, and this is 38 degrees now. We're getting closer to the end. Take a look now at the measure of arc XU. It's right here. If we had the measure of that arc, we could find the measure of this angle. And we could find the measure of this angle by the tangent chord theorem. Notice this angle intercepts this arc right here because it uses a chord right here and a tangent right here. But before we can do that, we need to find this right here, this measure. Well, it just so happens we have all the rest of part of the circle, the measure of the rest of the circle here if we'll add them together. So by arc addition postulate, we can say the measure of arc XU right here plus the measure of arc UV right here plus the measure of arc VW right here plus the measure of arc WX right here all the way around gives us the number of degrees in a circle, 360. Substituting in what we know, of course this is what we're looking for to go on with the problem. So the measure of arc XU plus the measure of arc UV is 110 degrees plus the measure of arc VW is 70 degrees plus the measure of arc WX that gave us is 76 degrees equals 360 degrees. We combine these like terms or add them together. We get the measure of arc XU plus 256 degrees equals 360 degrees. Subtracting 256 degrees from both sides, we get the measure of arc XU is equal to 104 degrees. So even though this isn't one of our answers, we're going to use it. This is 104 degrees right here. Now we can use the tangent and chord theorem. So by tangent and chord theorem, we can state the measure of the angle UXC must equal half the measure of arc UX or XU. Substituting in what we know, the measure of angle UXC is C degrees equals 1/2 times the measure of XU, which we found a while ago to be 104 degrees. Half of 104, or 2 goes into 2 once, 2 goes into 104, 52 times. And so C degrees is equal to 52 degrees. We come over here, cross out C, and write 52 degrees. And we have now found every single variable that they asked us to find.